Hey, hello everybody. Welcome to another class. Let me check if everything is fine here. Let's wait a little bit. Thing is fine here. Let's wait a little bit. Thing is fine here. Let's wait a little bit. Okay, looks like everything is fine here. Let's wait a little bit. Wait. Okay, so in the today class, we'll solve the exercise I put in this file here. So we learned basic stuff so far. So input, output, some assignments, and then math operations. That is enough to do like some good stuff. So I want to plant a seed in your mind about how we can or we should proceed to understand a problem and then come with a solution and then write a program. Let me check something here that I'm kind of, and then write, yes, because one thing that we should avoid is to rush to start to do the coding. One of the most common, wait, let me fix this here. So look, we are using this file. Let me just hide this here. One of the most common mistake during code interview is the candidate just read the question and start to do the coding. And this is not what is expected. What is expected is that you make sure that you really understand the question. Then you can think and explain how do you think is a good way to solve it. After some talking, then you go do the coding. Never ever in your life just read a program or get a specification and start coding. Before you start coding, have a plan, at least like create an algorithm, some drawing, some text, just explain your idea. That is very important for the code interview, because one of the abilities that the companies are looking for now are engineers that are able to communicate. Because during your work, you need to explain, to debate, to defend some ideas, to criticize some ideas. So it's important that you have that communication skill. We have the ability to think and then explain what is our thought process. Okay, give me a second. I'll close the window there because it's kind of a little bit loud here. If you join now, I'm still here. Just closing some window. Okay, good. So I will do some role playing just to help to help you to understand a good approach, because you see different ones, how to come up with a program. Okay, so let's get the first question. Question number 1. So let's celebrate. This will be our first program. Oh, actually, no, we already did other ones. No, we did those ones for those thing here. We read and create output. But the first program, doing some calculation. Okay, so let me just close this and let's see. Read a speed in miles and convert to kilometers. So the first lesson is we cannot come up with a program if we don't know how to solve the problem. Because as we learn, a program represents steps in a program language that will serve a particular problem. So it's very common for example, I was already a professor, I was like a coder for many years, and I was visit a friend, and they said, oh, do you know, my son is doing engineer, civil engineer, mechanical engineer, and he's doing a coding course, and could you help him? I said, yeah, let me try. And then my son friend was using like MATLAB to solve some equation or something that I didn't know. I said, well, you have to explain me first. If I'm able to understand how to solve the problem, then I can come up with a program for it. So that is the lesson number one. The most important part is we understand the problem, and before we even think about coding, we have to find out a solution for it. Because if I don't know how to solve the problem, if I don't know the solution, how are you command or how you teach a machine that is extremely dumb to solve it? Okay, so remember this. Let's see this. So we will start with very simple problem, but even those, most of the people don't know right now. For example, read a speed in miles and convert to kilometers. So this is very common. You go work in a company, maybe you are working, I don't know, like maybe a game, or maybe like a car company that need to calculate the thing, and you get the task. So most of the time, you don't know all the details of how to solve all the problems. You have to do some research. So that is what I want to do here. In this case, well, I don't know. I have a guess about how to convert, but it's very common for us to need to look for information. Right now, I'm working in a company and our product do accounting. And I'm very fresh in accounting, like accounting theory. I'm not accountant. So I am working some tasks that my task has to do accounting. So I have to, here, I just bought like a book to learn more about accounting, to understand what I'm doing. But I have to talk with people. Oh, how I do this? Like when I get an invoice, where should I put the money? Like in the account, is credit, is debt, where it goes? So the company has some accountants to help us to build this system. Otherwise, how come a software engineer will do a system that is going to do accounting if we don't know accounting? So that is what I'm trying to show you all here. Most of the time, we will be working with a domain or a business area that we don't know. We are not comfortable. We have to learn. So after you are in a position for a long time, you become expert in that domain. But when you change or you join a new company, you have to learn all again. For example, I was working in a real estate company. I knew nothing about real estate when I joined. I have to learn. I joined a financial company. I did nothing about like banking. I have to learn about it. I joined Microsoft. It was like big data, and we are supporting the e-commerce. I have to learn about the business in Microsoft, because every piece of code we will create has to solve someone real life problem. We are being paid to produce a solution that a computer can execute to solve a particular problem someone. So in this case, don't get scared if you say, oh, is every developer so smart that they know all those answers? No, we don't. The only thing we know is, as long as we know how to solve it, we can translate in an algorithm and then later on in a coding language that a computer can execute. So how we do in this case? Usually I put the formula here, but I want to show you how common it is for us to need to ask. So for example, in this case, I could already ask like Copilot to create a Python program for me to do this. But I will simulate here that is not what we want, because we want to learn how to create a program. If you ask the AI to create for us, we're not going to learn. However, it's not a problem to go there. Like, let me go to Bing, Copilot, and say something like this: how to convert from miles to kilometers. Sometimes people think, oh, I'm gonna use Google a lot. Google, ChatGPT, you ask someone, you have to ask the business people, because if it's a business related to your company, ChatGPT does not know, Copilot does not know, and it's not in any book. You have to talk with business people, the business analyst that is going to explain you how to solve that problem. And then let's see what they will come up, a solution. So convert miles to kilometers quite simple. You can use the following formula. Do you see here that there is some strange format here? Probably Copilot got lost in the interpolation. So we say kilometer is, we have like, as I am a human, I can understand this, but if I was giving this to a computer and he was expecting a specific way, so look, kilometer is equals to miles times multiply by 1.60973. Oh, 0934. So I will copy that formula. I basically can copy this number. Well, I will copy this. Yeah, I can copy this right now. So I will prepare to write my program. So I will come here and I will create a new file that I will call underscore 06 underscore 01 and then underscore practice and then py. Actually, I will do different. I will rename this. Where is the rename? Actually, I will do 06 practice 01. So they stay in a nice order. No, how I do this? I want this file to be after this one. Oh, wait, there is something wrong here. Practice 01 underscore, oh, I know. I will get this guy here and I will rename to be 00. Now is go to the order. Okay. And I will copy the problem just to help us. I will copy this here as a comment. And then I start to solve. Okay, let me hide this. I will copy the formula here. I will say like kilometer. Oh, kilometer is equals to miles multiply by this. So this is a very easy problem because I just need to figure out, oh, there is an expression for that. So I say, okay, now it's time for me to do the input. If it's an interview, it's very important you to ask, oh, what is the type of the input you want? Miles will be always an integer or could be a float. Probably as a float, because when you talk about miles and kilometers, sometimes we imagine it as a car that goes like digital. We go 70, 71, 72, 73. So there is no decimal there. All depend of the problem. Don't assume, always validate in an interview and in real life. There is a lot of bugs that come from those assumptions. For example, I could say something like this. I read miles, so my input will be miles. We receive an input. And I will type here like miles. Oops. Remember that this input will come as a string. So in this case, you would say, okay, I want to convert not to integer. Because if I assume as the most fitable one. And we remember when we are doing the input, output thing here. Oh, not here, was somewhere we saw that conversion. Was here. See, float and the input. It's very common for us to don't memorize, and you can go there and look. So when you join a new company, there is a lot of code already there. So we go there and see, oh, how they do this. For example, right now I'm working with a new language. I never worked with Kotlin before. But there is already a huge code base, and what I'm doing, I'm validating how they do, because then I keep the same kind of style, code style. When there's something new, I double check if it's in a good way. And there is a process to review, make sure that we follow all the rules. So what I like about coding is that you don't need to have a strong memory. You can, when it's needed, you go there and check how to do it. So look, now we have the miles that was input to us. And then we can say, okay, in kilometers, will be miles multiplied by this value. So that means 1 mile is 1.6 kilometers and something. I could be like, say, just 1.6, but it's better to be precise. And now that I have the input, I calculate the miles. This is the input, the process, and then I will prepare my output. So I would say something like print. I will put that little f in my string to format my string. And I will say miles in is kilometers, and then I will put a km here, or something like this. In our question was not told, it was not, we didn't get to tell how to put the output. So then we can choose, if it's an interview, you can say, oh, may I show this way? This miles is this much of kilometers. Okay, so let's save. Remember, never assume that your program is correct, and always test with the intention to find bugs. During interview, that is very important. You have to make sure that the interviewer understand that you have that in your coding style. Okay, let's see now. Let's run it. And here is ask for miles. Let's put here like 80 miles or 65 miles is the maximum speed in most of the highways here. I'll hit enter, and they say that 60 miles is 104.6071 kilometers. If you want to make sure, we can say this, or how much how much or how many? That I can now do it. So converting 65 miles to kilometers. What is the result? So we get this response. So we say, okay, we will learn later on how to do all the testing. Cool. So we test a few times, and then we can make sure, okay, now it's cool. But make sure that you always try to understand the problem, check for the domain of the data, because maybe in the context that you are working on, the miles will always be an integer. Imagine like those cars that they only show 81, 82, 83. There is nothing like this. For example, 65.35 miles. How much in kilometer is? Okay, do you see there is this? So we don't own this. The business owns the types. When we are in doubt, we put the most. Imagine that I have the requirement on a Friday night and I have to put in production and I'm not sure what type is. I make float because float support integer and floats as well. But ideally, before you start to code, it's good to make those questions. A good engineer is the one that will make those questions, and if does not have answer, will do good assumptions. With time, we learn a lot how to do those things. Cool. So this is our first program. We do some operations. So we have here like the input, the processing, and the output. I don't think it would be a good idea to have something like this, for example. Instead of calculate that, put all the expression here. We'll have the same result. 65. But the bad thing is that we are calculate the value while we are generate the output. And it's very common for us to need this to do something else. So it's good to store because maybe later on we will print and you do something else. So always have that in mind. If you're going to calculate something, store in a variable. And then you use for print or whatever you need. Okay, so great. What could be wrong with this program that we cannot fix now? We will learn how to fix this. Will be later on when we learn about exception. If we run this program right now, and by accident, the user type like a letter, we'll get exception saying 14K cannot be converted to a float. Okay? We don't know how to solve this yet. We will learn later on. But just understand that a lot of programs will have some chance to fail because the input is not the way that you're expecting. So for now, let's just have that. Okay? And let's close this and let's move to our next program. Our next program is very similar. It's just read a speed in kilometers and convert to miles. So let me copy this here. And let me duplicate this guy. I guess there is no duplicate here. There is no, but I can copy and then paste. And I rename this guy. There is plenty different ways to do this. I am doing this just for. And I rename here to 02. And I will kind of almost remove everything here. Oops, sorry, not this. And then I will copy the problem here. And now I could, as I knew already how to calculate from kilometers to mile, that if I want to find miles from kilometer, I just going to divide kilometers by this value. So look, this is basic math. If you're in doubt, we can abstract math. There are very good code engineers or software engineers that they don't like math because when this is needed, they can ask for someone. But it's good that we develop that, like understand to do some math. So if we learn like some basic math, we can say, oh, when we have a situation like this, we can move this to the other side going down. So this means if kilometers is equals to miles multiplied by this constant here, that means that miles is kilometers divided by this. If you don't know this, it's good to review some basic math, but this is not going to prevent you to be a good software engineer. a good programmer or to find a job. With time, you may learn that. What you could do, you could come here and say, how do I convert from, now is the inverse, no? From kilometers to miles. So he should be showing here like mile is equal to kilometers, multiply by 0.6 all this. So basically it's divide by that. Okay. Let's go here and let's follow this. We say, okay, let's get this here and let's go to our practice 2. Don't feel bad if you don't know the math or the logic for the problem that you are solving. That is very common and you help a lot. Wherever you're going to work, some point you're going to be dealing with a business that you never did before. So you have to ask for help. And now I say, okay, basically it's the division by 1 dot. So if we clarify, is basically that. So we say here that miles is equals to kilometers multiplied by this. Let's see if there's, and the good thing about software is that sometimes we are not 100% sure about what we do. We make our problem and then you test. That is why it's very important to think about testing. A lot of time, we don't know exactly how to solve. We build up our solution step by step. So look, in this other one, we read miles. Now we read kilometers. So our input will be kilometers is equals to float. We will convert this input and we'll say kilometers. Kilometers or kilometers. Let me put like this. Kilometers. Okay, and then we say miles will be kilometers multiplied by this. What I'm trying to show you is that sometimes we can abstract the low-level solution for the problem as long as we can find the equation, the explanation, or what you need to put there. I don't need to prove you mathematically that this is the right operation. I just say, okay, this is what you need to do. And we can ask this, could I assume that to convert kilometers to miles, I would divide by what is divided by this? I hope I'm not confuse you, but what I'm trying to tell you is that the Copilot or whoever the person was tell us how to solve the problem just gave us a different equation that means the same. And sometimes I'm using this example just to expand our mind about how to do with code. Sometimes, as long as you have the equation, we don't care. So now I'd say print. I use like permutation, so little f. And I say this value kilometers. I put now the string kilometers is, now I put the value of the variable miles. This will be the value of this variable. This will be value. We already learned about that before. And then I see this. So he gave an example here. 20 kilometers is approximately 12.42 miles. So let's use that to test. I save and run. And I put like 20. And then it's saying that is 12.42743. So do you see here that they are using like 2 decimals? We could use some math operation to do the roundup. We learned about that. Do you remember? We could say round or something like that, but we don't need to do here. If you are in doubt, you could say, okay, could you... Oh, wait. Give me a second. Oops. My son called me. Could you give me some more examples to test? So what I will do, I will test my program with all those values. And we will learn in the future one thing called unit testing, that we will prepare another program to test this one with the results that we know. Just to make sure that if someone changes the code, it's not going to break it. And I can say, oh, please, oh, I guess, sorry, the conversation is end. Okay. I would say, please give me some float points to see the result. But just to show you that it's important to do all those tests. So kilometers, 200, miles, 124, 27. Cool. So I had some students being blocked about learning code because they said, well, I don't get this math. This is complicated for me. And later on, there is other stuff that is complicated to anybody. For example, if you are working a game and you need to calculate the area, the surface, that is already solved. We just need to get the equation and you translate that equation here. So the computer or the program language will do the computing. That is interesting. It's called the power of abstraction. We can solve a problem that we don't know all the details about the solution. It's like to drive a car. Most of the people can drive a car, but almost just a little percent of people know all the details about a car engine. What happened in a car for that car to run. It's the same with code. So what I'm trying to explain you is that don't feel bad or don't feel that, oh, I cannot do coding because you are not understanding some of those math. You just need to know, well, I'm going to read this value, I will do this calculation, and I will print it. That happens even with advanced software engineer. Depending on the field that they're working on. For example, they are working for a company that do tax. There is a lot of calculation. Someone is going to tell you, in this case, use this expression. You are working with accounting. In this case, you use this expression. You are working on e-commerce. Oh, to calculate this product or calculate this, use the expression. There is other areas that bring us those expressions. So we don't need to be expert in everything. With time, work in a company that does certain type of business, we will learn about it. I work, for example, many years in a bank, so you learn about bank stuff. I work many years in a real estate company. You learn about real estate company. Then I work many years in a fintech company. You learn about fintech. And now I'm working in a company that does accounting. And then I'm learning about accounting. And I find it very interesting. I'm like very eager to learn because I feel bad that I go to meeting people about like talk about credit, debit account, credit account, and then bookkeeping and ledger. And I said, oh my God, what are they talking about? So that is common. It's how you may be feeling now. Whoa, what the heck is this? How calculation? Abstract that. With time, we'll learn how to once someone explains you the solution for a problem, you translate it. And then you translate, sometimes you forgot. But your code is there. If you need, you can go there, read your code, and figure out what is going on. Cool? So that is my message today. I want you to be in peace in your mind that coding is a tool to allow a computer to solve a problem for us. But we must give the solution. And that solution, most of the time, we don't know all the details. We have to figure out, we have to Google, we have to ask someone, we have to check a book. We have time and you can build slowly our solution. Okay, so I'll close those two. And let's go to the next exercise. I try to build this exercise in a way that we may be using everything that we learned so far. So all those operations we'll be using here at some point. The first one was just expression. And my goal was to show you this, that sometimes we have no idea how to create that expression. We have to get for someone. But there is everything we're going to learn here. So the next one is read an integer number and print the three predecessors and the successors. So let's copy this. And let's create our program there. For a new file will be _06 underscore practice _ 03. Yeah, I forgot the, let me go to rename. I forgot the dot py. And let me just hide this here. And this is our program. One thing that I will tell you now, probably you have the same, feeling that most of us have. Oh, let's start typing. No. Let's learn to do something like this. I kept this here just to show you that always in your mind have those divisions. Right side, we are understanding the problem, find a solution for the problem, represent that solution somehow, and after I understand that and I validate, then we go to the coding. If something is missing during the code, we find something wrong, then we refine. We may come back here to get some more understand, and then we finish our problem. Never ever jump directly to code. Okay? Right now we have some easy problems that is hard to prove you all how important it is, but let's think here. We have our program. Okay, let's think that this is our program. What we need to think, I guess it's this, no? We have our input. Let me do this first. Format, line. I need like a better line. Okay. We have an input. What is the input in this case? We need to read an integer number. So I say, okay, my input here will be a number. Our program will do the processing. And I have to think, what is the output? What should we, oh, it's not a good, What should be our output? Well, as I can see, like the three predecessors and successors. I can easily understand that it's the three predecessors and three successors. I could confirm, oh, do you want to three predecessors and one successor? But as is in plural, I assume, oh, this is just something like that. So we need to understand that our output will be something like predecessor 1, predecessor 2, predecessor 3, and then successor 1, 2, and 3. This is important for us to assimilate. We will use our imagination to think, okay, what is this problem? What I have to get and what I have to give. What is the input and what is the output? Because this way, we will figure out what is our processing, what is our logic. So we can put some values here. For example, if our input is 5, what should be our output? So here we can say, okay, which order is expected? Because this may be important. 3 predecessors. So should we output 4, 3, and 2, and then the 3 successor, 6, 7, 6, 7, and 8? Or should we output 2, 3, 4, 8, 7, and 6? So if there are 2 candidates interview for the same position, and one candidate just assume that that is the expected order and just code for that, and the other candidates say, oh, do you know, how do you want me to print? Which order? And they may say, oh, I want them in natural order. So I want the first 3 in the natural order, and then the next 3 in natural order. So it will be like this: 2, 3, 4, 6, 7, 8. So the second candidate demonstrates more maturity, because he said, oh, I don't want to assume. I know that could be different order. So let me ask, let me confirm. So do you see my point? It's like this. We don't control how our solution should work. The business does. And we have to always check that. Otherwise, we will be causing bugs, because maybe the business is expecting this way, maybe not. So we will maybe solve it 2 ways, so we learn more. So let's go. I don't need to ask what is the input type, because it was already told. Integer. Make no sense. Say, oh, is an integer? Are you sure? Yeah, I told you. So then we can say something like this: number will receive a conversion from integer from the input, and here we can just say number. Okay, so now we have an integer. We could maybe do something like this. For example, let's play some options that sometimes only comes during the coding. Maybe here we cannot express that, but we could do something like this. I say print. I will do an interpolation here, so I will put a string with f, and then I say, okay, 5 for 2, if I wanted 3 predecessors, will be number minus 3. Then I put a space, another replacement, so it will be now number minus 2. Now number minus 1. So in this side, I'm getting this. 2, 3, 4, if is 5. Now I'll put another space, and then will be number plus 1, another space, number plus 2, another space, number plus 3. If I didn't do any of the thinking here, I will miss this possible different ways to print. And then I will show my interviewer that I am not that experienced. So let's run this just to see how it goes. So if I run and I put my number like 5, I will have 2, 3, 4, and 6, 7, 8. Because this is the way that we confirm with the interviewer or with the business people, the business person. However, imagine that another candidate, he thought, well, you know, instead of just generating this string directly, I will do like this. I will use some extra variables, predecessor 1 will be number minus 3. Predecessor 2 will be number minus 2. Predecessor 3 will be number minus 1. Successor 1 will be number plus 1. Successor 2 will be number plus 2. And successor 3 will be number plus 3. And now I would have my print. And instead of do this calculation here, I will put like predecessor 1, predecessor 2, predecessor 3. And here would be successor 1, successor 2, successor 3. Imagine that when you show this, the user says, no, sorry, I want the successor, the predecessor in one line and the successor in another line. Then you can say, okay, I will do a breakdown here. I finish this string here. I will close that print. I will make another print. I will put a little f and this. So now what did I change? I think this solution here, even we using more lines, way more line, is better than this one. But then this is debatable. Depends of the case. If your function is just doing that, okay. But what if you needed to use those predecessors 1, 2, 3, successors 1, 2, 3, later on to something else? So it's good to always calculate and store. Okay? So let's save, run again, and let's test with the case that we know the response, 5. So now we see the 2 lines, no? Oh, the 3 lines, one all in one line, and then breakdown. This is just experiment, so depends. So sometimes we play and we show the user, this is what we like, and sometimes the user change their mind. No, I don't like this way. Give me one in which line. So you go there, you change. That happens all the time. Okay? And it's nice to test with something else. For example, imagine if I put 0. What is going to happen? Minus 3, minus 2, minus 1, 1, 2, 3. Okay? We can run again. If I put like 10. Oh, sorry. 10 here. will be 7, 8, 9, 11, 12, 13. Okay, so this is the seed I want to plant in your mind to help you to be ready to, even for easy problems, to think, okay, what is my input? What is my output? And what I need to do to get this output. Okay, so here we could maybe think something like this. Oh, it will be number minus 3, number minus 2, number minus 1, and then number plus 1, number plus 2, number plus 3. So we have 1 input and 6 output. So it's always good, at least for each output, to store them in a variable. Maybe an old software engineer could say, oh, this solution is way better because look, we have only 1 variable. But all this has to be calculated anyway and stored in the compute memory. So by having this, I just have a name for this calculation. And now it's easier for me to... What maybe you could do that people like is, instead of like predecessor, you could change this. Let's do a rename here to just pre1. Sometimes this is okay. And then you could change this to, rename to, instead of having the full word, I prefer that we type everything. Unless there's something very, you're going to say, this variable is intended to store the predecessor 1. This variable is stored the predecessor 2. No, something is easy to read. If you come here from like months later on, you can look and know what is going on. Cool? Pay attention that I'm going very slowly because I want to make sure that we all get this idea. We are doing simple thing, but we use everything that we learned so far because it's very important. Those are the tools that we have. And if we don't understand those, it will be hard to move forward. Okay? The second important lesson from today is don't get scared if you are reading a problem that you have no idea how to solve. That is normal. It's like math. There is no mathematician that knows the solution for every math problem. Sometimes they have to read and let me look for help. Okay? Same for a lawyer. There is no lawyer that knows everything. He has to face a problem. They go to the book, read petition, read stuff, and then come up. Doctor, the same thing. They see like some symptoms, some things, said, well, let's go this. He has to do some research. So people tend to have a hard time learning how to code because they think every software engineer is a genius that knows the solution for all the problem. And this is far from true. What we need to do is break down that problem in small steps and then be able to translate to a code language that we can play with it. We can try. So this is better than try to build something real because we don't have like the raw material that we will break or waste. Whatever is wrong here, we fix and we run again. Cool. And if there is something wrong, for example, if I put this like twice here, is that why we need to test? And yeah, feel free, Baladinha. Do any question you want. No worries. You can just put the question there. And then I say, okay, 5. And then I see, oh, 6 twice. So I have to go here and because we do a lot of those mistakes. Okay? Feel free. Go ahead and shoot your question. No worries. And by the way, next time, just put the question there. You don't need to. Okay, so I wait for the question and let's go to the next one. Actually, by the time, let's just like, what I'll do now is after the class today, if you didn't finish all those, try to do it. Do the most that you can. Keep following this idea and try to practice this. Find a piece of paper or anything like that. You have to draw something that will help you to understand the problem. Let me make this like, let's see. Now we are waiting for a question. I hope it's not a prank. Da, da, da. Well, what you can do is put your question in the chat and then I read and respond later on. So I wait 1 more minute and let's see how it goes. So I wait one. Well, YouTube is showing here that there is no one online, so maybe something happened there. So feel free to post your question there and I will answer. Okay, so I hope you all got the class on today. We only solved 3 problems, but I'm not in a hurry. I want to make sure that you all can follow that. And I want to give you some advice what we'll be facing while learning coding. Cool? So see you next class and peace. Bye.